Let's take a look at the next example. This time we have yz in the second term and y square z square in the third term. What I'm going to do, I'm going to use the properties of exponents and I'm going to rewrite this problem. I'm going to write yz inside of the parentheses because I have also yz over here. To the second power. Remember what we said? Anytime we have the same variable or the same expression in the second term and in the third term, but in the third term this expression is raised to the power which is twice of the power in the second term, we can ignore this expression. That's why I'm going to write x squared plus 6x plus 8. Next, I have to perform regular factoring. I have to look at the signs which are next to the third term and second term. Positive sign next to the third term is telling me that both signs in my factors are the same. And because I have positive sign next to the second term, the same signs are positives. Next, I have to find two numbers which are multiplied by each other are going to give me 8, and two numbers which add to each other are going to give me 6. These numbers are 2 and 4. And I have to get x squared. I can get x squared by multiplying x times x. Next, we're supposed to bring yz to our answer. Because the first term of my quadratic trinomial doesn't contain yz, I have to add yz to the second term of each factor. That's why I'm going to have x plus 2yz and x plus 4yz. Let's check if this is correct answer. X times x gives me x squared. X times 4yz is positive 4xyz. 2yz times x is 2xyz. 2yz times 4yz is 8y squared z squared. We're supposed to combine the like terms, and I'm going to have x squared plus 6xyz plus 8y squared z squared. Please look at this trinomial and this one. Both of them are identical. It means that this is the solution to my problem. Let's take a look at this example. Please notice that in the second term we have bc, and in the third term I have b squared c squared. I'm going to rewrite this problem and I'm going to use the properties of exponents in order to make this problem looking a little bit simpler. Plus a, and I'm going to write inside of the parentheses b c minus 12 bc squared. Remember the rule. Anytime I have variable or expression in the second term and third term, and the expression in the third term is raised to the power which is twice of the power in the second term, I can ignore these two terms for a moment and simply write a squared plus a minus 12. Next, we're supposed to perform regular factoring. I have to write the parentheses. These two terms, which I'm going to write first, multiplied by each other, are supposed to give me a square. They are a and a, because a times a gives me a square. Next, I'm supposed to find what signs I'm going to have in my factors. Negative sign next to the third term is telling me that both of them are going to be different. So one of them is going to be positive, another one is going to be negative. Positive sign next to the second term is telling me that the bigger number is going to be positive and the smaller number is going to be negative. These two numbers are 4 and negative 3. Why? Because 4 times negative 3 is negative 12. 4 plus negative 3 gives me 1. But this is not the solution yet. Remember, at the beginning, we had BC's in the problem. We have to bring them back. Because the first term of my quadratic trinomial doesn't contain BC, I'm not going to write any BC next to A's. Where am I going to write them? Next to the second term of each factor. I'm going to write A plus 4BC times A minus 3BC. Let's check if this is correct answer. A times A gives me A square. A times negative 3BC is negative 3ABC. 4BC times A is 4ABC. 4BC times negative 3BC is negative 12b square c square. We're supposed to combine the like terms, and I'm going to have a square plus abc minus 12b square c square. Now let's take a look what we have got and what we had at the beginning. These two expressions are identical. That's why this is the solution to my problem.